Okay, is this mic working? Can you hear me? Oh, great. Okay. Well, I'm Adam Clivens, and thanks for coming to day two. I'm excited for this panel. We have a very interesting group of people here to talk about all the hottest issues in AI. And so I'm going to very, very briefly tell you who's on stage, and then I'll have them sort of tell you about what they're interested in AI, and then we'll get into some super controversial and difficult questions. So to my left is Zaib Hussain, who is an international entrepreneur and VC, runs Hyder Ventures, is also a partner at founding partner at Global Ventures Bridge, and has been working in AI and finance for 25 years. She is a graduate of UT Austin, and is one of our patron saints of the Machine Learning Lab. Thanks to your philanthropy, we're able to hold events like this. It's great to have you here. We have Harry Tor, who is the Chief of Staff for the Linux Foundation. And Harry is particularly interested in security and AI, and is a world expert in these issues. And then we have, sorry, I don't have your name on this. Are you supposed to be on this panel? Yeah. Sorry, who are you? No. Alex Demakis, we have here, AI noob, as I mentioned on the Slack channel, who I'll be roasting during this. So Zaib, start us off. Tell us, what specifically some of your interests are, what sort of things you're worried about in AI right now.
Yeah, so first off, thrilled to be here. It's always exciting to be on campus, and so many amazing events this week. In AI, you asked what I'm worried about. I'm thrilled and excited about more things that I'm worried about, but I'll touch on a few that I am concerned about. And I kind of divide them up into three buckets. One is just kind of pure software risk, which is where you're seeing, kind of the deep fakes emerging, news stories that we may or may not be able to trust, people, assuming identities or stealing data, that sort of thing. And so that's a whole system unto itself. But then there's also embodied AI, which we're coming upon. We're going to have, there are already a lot of smart robots out there, but with the humanoids revolution that's underway, we're going to see, robots that look and feel like humans out there. Some kind of a little concerned about that interplay in society. How do those robots, those machines mesh with the fabric of society we have now? And I mean, down the road, I'm a little concerned about what all the displaced humans are going to do. Hopefully it's something fun and exciting, and we get to live lives that aren't bogged down by trivial tasks. But I think we're a long way from there, and we may see some of the more, some of the not nice effects come out first, with people losing jobs, not being able to retrain on what's the latest and greatest requirement in the workforce. And I'm a little concerned that policy and regulation is lacking in those spaces.
Harry?
Yeah, so I'm the chief of staff in the security portion of our foundation, right? So the Linux Foundation maintains the Linux kernel, which many folks are familiar with, but also thousands of other pieces of open source software. And what I'm worried about is everyone downloading the wrong piece of software and using it in their AI systems, right? Which we think about from a standpoint of data poisoning. That's a well-known topic, right? But what if your code that you're downloading leads to data poisoning or leads to adjustments in your weights? How do you know that even? Because code is executing behind the scenes. So when you look at the supply chain of open source software in AI, it's not very well understood. It's changing all the time. So the concern is, how do we develop capabilities to secure that supply chain, do it in such a way that isn't a burden to maintainers of those open source software, and do it in a way that's also reasonable, right? We want the innovation and the entrepreneurship to happen, to continue to happen, without security being a gating function. So that's what I'm worried about.
Alex, I think one question that's on everybody's mind, and I wanted to ask you this, is what do you think of the new Taylor Swift album that just dropped last night? The Tortured Dead Poets, the Tortured Poets Department.
Is that an actual Taylor?
Okay, okay, you don't want to answer that question. That's fine. So I've had to sit through, many of your talks where, over and over again, I see the picture of the stop sign where somebody has placed a sticker on the stop sign, and then an advert, and then, some model decides it's not a stop sign, it's a gun, or it's a turtle. The constant fear of the adversarial examples. And now I don't hear anything about them anymore. So I'm wondering sort of what happened. Have people given up on that? If we just decided to accept that as inherent in the system, or, why did I have to sit through all your talks about that? Yeah.
Okay, good. All right. So the problem, just to make sure everybody is on board here, is that I don't know anything about Taylor Swift, so as Adam knows. So the adversarial attack problem was that people found out that when they they can manipulate an image and it can completely fool a classifier. The most striking example was these adversarial stickers that people would put on stop signs, and they would be classified as speed limit signs. And they said, oh, this is going to be a huge problem for self-driving cars. The short answer is, I think what happened is as we expanded our training sets from millions to billions, and we got basically CLIP, which is, we had ImageNet, which is 1 million images, right? And it was very easy to to adversarially attack ImageNet classifiers. But when we got to CLIP, which was trained on the billion scale, we found that it's actually much, much more robust to both these adversarial attacks, but also what people call spurious correlations, which are not adversarial. Like the example I gave there is, camels, in a forest, right? So a classical classifier would detect camels in the desert because all the images of camels are in the desert. But if you show it a camel in a forest, it would think it would be easily fooled to think it's another animal. But when we got, I think, to the billion scale data sets, and we go to the new generation of foundation models, like CLIP is specifically the one for images, it became much more robust. So I think the adversarial attacks are still possible, but I think they're much less robust now. So I think that's why people are,
Wait, the attacks are less robust, or
the models are more robust.
The models are more robust.
Yeah, but the attack being robust means also if you just recrop the image and add a little bit of noise, it's gone. So it's a weaker attack, basically. Yeah. So
I see.
yeah. So I think that's what has happened. But there's new types of attacks that are emerging now for language models, for example. And it's about, leaking social. There was a very recent paper that said that you can add some gibberish text on ChatGPT and get it to output social security numbers, credit card numbers, I think Bitcoin wallets. And one of the attacks involved some actual machine learning where you had to do gradient descent in Llama to find this adversarial string.
What does that mean, doing gradient descent in Llama?
So you have Llama, you're saying I'm going to add this string so that the output is, sure, here is how you build a bomb, blah, blah, blah. And because Llama, you have the model, you can actually update that string to maximize the probability that this output is produced. This was Zico's work, and many others are doing this. But some other attacks are still completely mysterious. I think one attack that came out was repeat the word, I forgot the word, apple or something. Repeat the word apple forever. That was the attack. I think, does anybody remember the word? Poem. Okay, thank you. So it was repeat the word poem forever. Okay, so the model will be like, okay, poem, 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 poem. And then at some point it starts spitting out training data. And I think that's where they said that, and that to me is, I have no idea why that happened or how they even found that. So, but that's a very different type of attack than the ones that we know. So these things are behaving in very bizarre ways. We think we're aligning them, but it's such a vast, internal system that wears a little mask that seems to be a helpful assistant. But the moment you get out of distribution, people are discovering it's behaving in very unpredictable ways.
Harry, what are some of the most insidious attacks that you're seeing right now?
I mean, some of the most insidious are where people are taking over the original maintainers' lives, right? We had a recent attack where the XZ attack, where an unknown individual became the primary maintainer of the XZ, which is a compression tool used in a variety of, used in everything, frankly. And that would have, what the unknown individual did was basically introduce a backdoor into this tool, which would have allowed that person to take over virtually every system using Linux in the world. And so that'll happen because one maintainer was burnt out and and decided to cede this to this unknown individual, the maintenance of this tool. But when we look at that from an AI perspective, right? When AI starts acting within the development lifecycle and starts introducing code itself, who's there to police that, right? That becomes an attack vector that's scalable as well. So while we've gone away from like stickers on stop signs, we're now into, the world of James Bond, frankly.
So if I may add something here that I think is interesting is, everybody knows NumPy and Pandas and these type of tools. So when you import Pandas, I suppose the person who's maintaining, Pandas is, well compensated and like it's a big team and I don't know, but I think there's a million tools under the hood there that are tiny little tools as that we don't even know about, but they may be in the dependency chain of things we all use every day. And then it's, who knows, maybe it's just like one random person somewhere so that's something that's very surprising to me, but maybe you can tell us a little bit more about.
I mean, it's both an opportunity and a risk, right? There's an opportunity for folks to build tools to catch these nefarious actors or this nefarious code, right? And the risk is that those same tools are contributing to the effect. Yeah. And so I think it's really places like this, like UT Austin, where those tools would be developed, right? We have to start with fundamental research to do this. And there's a lot of good work going on with DARPA. If anybody's looking for a DARPA grant, they've issued quite a few items related to this. And right now there's actually a cyber challenge ongoing that we're supporting with DARPA. It's called AI XCC or AI Cyber Challenge. It's based off the Grand Cyber Challenge that they had a few years back. And that's a competition to have AI find and fix vulnerabilities in code. And so sounds simple, it's incredibly complicated. And the field is just, I don't know, blowing up every day.
Harry, when I'm installing pip install PyTorch,
yes,
how many packages am I getting? How many dependencies? Order of magnitude.
Or I mean, it could be hundreds, could be thousands, okay. Right? And then if you just go, if you don't even do it with a command line, if you go out to GitHub and you just look it up, right? How do you know which one's the right one? And what's interesting from that standpoint as well is who's signed what artifact. We were talking about this earlier about verifying cryptographically that you're getting the right package from the internet, right? So that's a possible capability that could be introduced for AI systems as well, down to the data level.
Zabe, I think one of the themes yesterday, and as we all, I think, would agree, that data is king. A good training set trumps everything else. Sort of globally, how are countries or organizations protecting their data, or what sort of access are they giving users and developers data? I mean, what's going on there?
Yeah, so I think everyone's caught on to that. For sure, data is king, and everyone is kind of jealously guarding their data now. We've seen a lot of paywalls go up. Everybody is aware when, this company has my data and what are they doing with it? Who are they reselling it to? Or how are they using it? That's one aspect. So I'll give you an example of a startup that we're working with. It's a Web3 startup by the name of Navigate. And what they're allowing individuals to do is, select the data that they're comfortable sharing, and then allow that data to go over to Navigate, where it's pooled, anonymized, and made available for sale to anyone who wants to purchase it. But the one difference is that it hasn't been scraped. It's been acquired with, someone's approval. And there is the potential for individuals to get paid for parting with their data. And it could be anything from data off of their wearables, so, health data. It could be purchase data online, really any data that they choose to part with. So that's one
Sort of a
aspect.
streaming service.
Sort of a streaming service, but individuals can pick and choose what they want to share, and then they will receive tokens. And when the value of those tokens go up, they stand to make a little bit of money. So, there is certainly that aspect. On the more government level, I do a lot of work in the Middle East, in Europe. What we're seeing is an increased awareness of the risks associated with, uploading your data to a cloud for, engineers to work on in a different location, and what security risks or what other risks that might open that data up to. I'm involved with a few projects with the government of Saudi Arabia, for instance, and they have very strict policies for keeping most of their data, especially the more secure data, in-house. And at this point, you not only have to be on the ground in Saudi Arabia, but you need to be working with within a secure system that they deem is secure. So that does limit the potential of what can be done with it. But it also helps to allay some of those fears they have about sharing that data. So yeah, those are some of the trends we're seeing. And I assume that people and countries and companies will continue to guard their data even more jealously. We're going to see that in the future.
And do you think this is going to be sort of, all of the myriad legal issues, is that going to kind of play out in sort of a global scale in the courts, or do you think we'll find sort of creative ways to let people sort of share their data?
So I think it's so new, all of it, that I think the legal aspects of it haven't settled at all. And I think we're going to see some lawsuits come about where,
We've already seen some.
We've already seen some, but I think we will likely see others emerge as well. So there will need to be some parameters around how data is collected. And that's kind of a longer policy discussion at this point. But I do anticipate legal challenges. I do anticipate, countries, companies, even individuals saying, hey, this was trained on my information, and I at least need to have a portion of whatever gains may have been realized from it. Or I want to pull my data. We were just talking about it. That's another option that individuals might have down the road, to say, hey, I opt out of sharing my data. But that's only as good as the verification behind it. How do we prove that their data really has been pulled and it's not being used without their knowledge? So,
I mean, Alex, you're known as someone who likes to flout copyright law. So,
Yeah.
I mean, with your data comp project, I
Yes,
know that
yes.
you've completely ignored all rules and regulations on that. Have you gotten pushback from companies, or?
Yeah. So thank you for this great opportunity to tell you how the data sets that are used to train all the foundation models that I know of are created. Okay, so I want to tell you how the data sets are created now, the ones that I know. So what's actually happening, the pipeline is always the same. You start with what's called Common Crawl, which is a nonprofit that scrapes the web, okay? So if you have posted anything on Instagram, on any social media, on Reddit, on Stack Exchange, or anything like that, that's just scraped on the internet, okay? Including images, right? So the data comp effort, and before that, the Lion data creation so the data comp we were involved in, and data comp is Lion 2.0. In both of those, we created a data set of images and captions that describe the images. And this has been the foundational data set that has been used to train things like Stable Diffusion, if you know that, OpenClip, if you know that project, and many, many, many others. Every big company, I think, is using a version of Lion or data comp, or has used a version of Lion or data comp. So anything that involves images, I think, is and uses billion scale data sets, uses the following process, as far as I know. You scrape the internet, then you have all these images and captions, and then you have a filtering process of deciding what to keep and what to throw away. Now, when people say my data, right? So you say, I uploaded this image on Instagram, right? And now I don't know if that's your data or not. I don't know what the terms and conditions say. That's one thing. So you could say, okay, we're not scraping Instagram, right? But now maybe some other person takes that image and puts it on Reddit, okay? And maybe they don't even say it came from Instagram. Maybe it doesn't even say who the owner is, and it doesn't say it was copyrighted. So how on earth, am I supposed to know where that image came from if somebody posted it on Stack Exchange? Or maybe, somebody's doing a student project like our students are, and they're creating, recognize bananas versus apples. They're going to do a Google image search, right? They're going to get all those images of bananas. Who knows where they came from? Then they're going to dump them in some S3 bucket because they're training their model. And I'm going to scrape that S3 bucket. I have absolutely no way of knowing their pipeline of that. So you say my data, and I'm like, the data on the internet is a mess. Okay. So you have no way of knowing what is copyright or not. You can try. You can say, for example, okay, if you want me to remove an image, I will make it easy. I will make an interface and I will remove it. Sure. We had a tremendous amount of work on filtering NSFW, pornography, violences, terrible things on the internet. And we had a huge effort, like grad students spent enormous amount of time. I think we did the largest filtering efforts that have been done in data comp. And another thing is personally identifying information. There is a lot of images of faces of people on the internet. And when we were curating those data sets, we wanted to blur all those faces. So we added a feature where we ran the largest face recognition effort, I think, that's been done publicly on 13 billion image caption pairs. And we filtered out faces. Now, again, there's all kinds of laws in every country that are basically making these efforts impossible. If you are to follow, the letter of the law, I think, depending on which country, these things would not be possible. So the question is,
So you are flouting the law.
we don't know. We don't know. I mean, the laws are also changing. But the main point is, do we want to have open data sets and open models? And then are the companies doing the same thing, right? So the first thing is, maybe a company that you have signed away all your social media images rights to can do it legally because you've signed that away without even reading the terms and conditions. Is that still a good thing? Is that because you can say, oh no, you're just taking from the internet, whereas the companies are good because the companies control, the social media platforms and they can do it. Again, I have no idea if the terms and conditions of social media companies allow them to train on that. I don't know. But the main point is, if you want to have an open ecosystem where a small startup or a research lab can train something like a llama or like a small model, like a small language model or a small clip, you must have the data sets and you must have the models. And it's a very complicated thing. If you put enough regulation there that say, oh no, nonprofits and universities cannot do these curation efforts, you think you're doing something good because you're protecting people, but I think you're also doing something very bad because you're encouraging a monopoly or an oligopoly.
I mean, Harry, do you think, is it possible that a closed ecosystem is just less fraught than?
No. I mean, we've seen that with open source itself, right? And like when we talk about open data sets, like why reinvent the wheel, right? Open source software runs everything. Right? 90% of goods and services shipped that are using software it contains open source in that 90%. And so foundations have figured this out, right? We have licenses that are open. We have models of governance. We were just talking about, how from a standpoint of if data needs to be added or deleted, right? Who's the committee to decide that, right? For open data sets. I would look to foundations that exist today to see how those foundations, those nonprofits can help with that. I mean, that makes, for one thing, you're talking about, I didn't read the terms and conditions, right? But when it comes to using software or using data on the internet, is there a document of principles that students, that engineers, developers need to look at, need to understand?
Does the Linux Foundation have any sort of, a template for best practices when it comes to data curation, or?
Yes, we do. If you go to Linux Foundation's AI and data group, they have that. We have principles for software repos as well. But we just maintain what is the community comes up with. So, we're at a standpoint, I think, of the communities to come together, whether it's students or developers in companies, and say, these are the things that we stand for when we're using data beyond the terms and conditions, which frankly are written by lawyers, and nobody's reading them, right?
I have a question for Harry on that. I saw that I believe it's Dana Wang at OpenSSF who recently said that the security and safety process needs to be kind of initiated sooner into, open source software creation. How do you feel that might change things, and how do you think things have evolved up to this point? Have we just been looking at safety and security in open source as a good to have or a nice to have, or addressing it as problems come up? And how might we prevent problems from coming up in the first place?
I mean, two-factor authentication, right? And the OpenSSF stands for the Open Source Security Foundation, which is the security portion of Linux. There's some basic cyber hygiene that we can do on your own systems, on your own laptops and devices that prevent foreign actors from influencing the way you work and your output. Apart from that, it's also recognizing the common good that everyone is doing when they're doing research and developing products. Because at the end of the day, we're not trying to create AI to destroy the world, right? As many would believe. We're trying to support economies. We're trying to support civil services. And in doing that, keep a mindset of how do you secure your workflow? Like, what should I be doing? And there's tons of resources out there to do that. We operate a course, Secure Software Fundamentals, taken tens of thousands of times. Surprisingly high rating for a security course. But there's stuff out there and it's free.
I mean, Alex, you're training a lot of your models on Common Crawl, and one thing that we've talked about that's been really difficult for AI for other domains, like AI for science, is that the data sets are now being sort of locked up. For example, DeepMind, their latest version of AlphaFold 3, they've basically told everyone that it will be a completely closed system. Academics won't have access to it. They won't be able to run it. They understand that big pharmaceutical companies, will have to pay large sums of money to license the software, because it's as people have realized, it's become more and more useful for developing new vaccines and therapeutics. So Common Crawl is great, and it gives aside from the myriad security issues with it. But what if we can't even, how do we even get the data for doing, AI for science when, big profits are at stake?
Yeah, that's a very good question. So one thing, I guess we were discussing this in an earlier discussion with Adam. One AI breakthrough that Adam, I think, believes is the most important one that is not getting as much airtime is AlphaFold. And I think that the significance of AlphaFold as a tool to create new therapeutics is impossible to overestimate. I think it's already becoming. I mean, Adam is much more an expert than me, but it is incredibly powerful new telescope that people are using, and it's having a huge impact to the world. Then there is huge monetary value, and I didn't know that, but it makes sense from a company point of view that, okay, we're not going to have this gold mine and give it for free anymore, and that is exactly why we need to have open data sets and open models. Now, the challenge in some domains is when you can crowdsource and you can collect from a lot of sources, you can benefit from that. I think otherwise you need open simulators, or you need big science efforts like CERN, like in Europe, and you need like these big billion-dollar investments from the government to create the centers that will open, like weather. I think climate is another very good example of releasing and creating open climate data sets and open climate models that require, hundreds of million investments in compute and in data curation expertise. And that's the only way we will have these. And these are, existential things for the world. So I think what we need to do is encourage governments to make, CERN-like investments for biology and for climate. Definitely two that come in my mind.
Or Harry, are we just going to move to a scenario where if you want a data set like that, you're just going to have to pay for it?
I mean, I'm aware I'm in Texas, right? I'm from DC. Like, do we want the government to tell us what to do, or do we just want to do the things that are right and benefit the world, right? Like, closed ecosystems introduce so many risks that we're not even aware of, especially when we don't know what those AI systems are doing, right? Like from a black box perspective, right? Open systems allow us to evaluate, allow us to reason, and allow us to change over time in ways that closed ecosystems just don't offer.
I mean, Zabe, you were saying earlier, I was interested to hear that the government of France was saying, right, that French data will not be used to build models anywhere outside of France or something. Is that
I think it was the government of Italy, was it, that said that their data cannot leave the country, something along those lines.
Surprising for the Italians.
Yeah, yes. And I do agree with you on having open source data sets that one can review and get expert opinion on. We did hear an alternate view from Scott Aronson yesterday, who said that having a few closed data sets kind of beats having so many open sets out there that you're not able to monitor, kind of oversee them. Of course,
I'm sure Harry would take issue with that.
Of course, but I was going to add, but Scott being who he is, he's most definitely a good actor with good intent. And so he's coming at it from that point of view. But what we're planning for is, the bad actors, the ones that we didn't anticipate and we're, we want to avoid. And those are the ones that one should fear. So in that sense, an open data set where you have many eyes on it, you have global collaboration, you have, people working together to keep it healthy. That is important, in my view. And then again, closed sets are more profitable. So we're going to run into that issue over and over again. And I don't have a solution, but I'm happy to hear your thoughts on it.
I mean, what about open weights, right? It's just not even about the data set. It's how do we get to a standpoint where open weights?
But that you mean but what exactly you mean? Open model weights? Or?
Yes, yeah,
Okay.
model weights. And I do take issue with the profitability of closed ecosystems, right? I think that profitability is monopolistic to some extent. And when you get to a federal regulation standpoint, there's problems with that, right? Acting as a cartel, for example. So, again, do you want the government to step in, or do you just want to do the right thing to begin with?
I want to add one thing here. So when we talk about open models, there's different levels of openness that I think it's good to bring to the table. The first thing is, are you releasing the model weights? The second thing is, are you telling us at least where the data came from and the mixture of data? The next level is you actually give the training data and the training code, which almost nobody does. I think the only exception is Luther AI and Allen Institute. The Dolma and Olmo data set and model, I think, is the latest great, truly open model.
Well, I mean, well, the stuff that you guys are doing at Data.
And the one that we're trying to do now, but that's not fully released. The code for an OpenLM is public, but the models that we're training, we haven't released the models and the data set, but we're working very hard to do that. And the other thing that's also beneficial for researchers is not releasing even the checkpoints as the model is training. So you don't just release the final baked cake, but you tell me how the cake was baking. And this is useful for a number of reasons, because I can go in some half-baked cake and do my own variation of baking. And that would be another thing that enables. So there's ranges of openness, and I think it's great that there's definitely great progress in the open models and open data sets community. And I hope and I see that we will be getting much more of that.
And I'll add on to that and say that the public's, general people's understanding of what's happening in this field is only as good as their understanding of the space, the technical understanding. And so it's important to have more people who kind of know the technicalities behind data training and LLMs and large data sets. And in that sense, the Masters in AI program, for instance, that's helping lower that kind of cost of entry into
$10,000 for a master.
Yeah, UT's
Thank you
doing
for the plug. Yeah.
well, it's I talk about it everywhere I go, because it's so phenomenal and it's so different from, hey, how much money can we make off of a single student that's going to attend the university? The thought process behind it is, how do we make this learning easier to access? And that's so important, because the more people out there who understand what goes into AI and machine learning, and the more people that have access to those people, you're just kind of widening the world's understanding of this very kind of mysterious field that's currently only understandable and open to a few people around the globe. So that's very, very important. And add to that the good systems and the ethics in AI, and you already have a number of people out there who are, hopefully using best practices and the good practices that are taught here and elsewhere.
Before I open it up to questions from the audience, one last question for if anybody wants to, field this question. I mean, what about, we were talking about data, what about sort of new algorithms or techniques for sanitizing the data set or pre-processing it or adding noise? Your student, Giannis Daris, of course, is doing incredible work on that angle. Does anybody want to talk? Is that a reasonable way to move forward, or?
Yeah, so we are doing work, thank you for the plug. We are doing work on training on noisy data. So one of the remarkable things that we're discovering is, especially for images, it's possible to see only very noisy images in your training data, but still learn the distribution of clean images, even though you're not actually able to see any training image clearly. So this is a very surprising thing mathematically, even fundamentally, but it is possible. So we created these ambient diffusions that are trained with very, very noisy data, but learn the distribution of clean data. This is one line of work we have been doing here. There is also a lot of innovation in architectures, like mixture of experts. There's also several other competing ideas, models that have also memory in addition to. So I think another fundamental algorithmic thing that's missing is you need the memory component. Like we know brains have a memory, which is a different process than, our short-term immediate process. So I think we need to add extra components. It's not just, we should just follow, the transformer architecture and we'll get to AGI, in my opinion. But of course, many experts are discussing those things. There's definitely a lot of active work there. And also on the data side, curating the data sets. And the other thing I want to say is, the dataset process is a bootstrapping process that builds on models. So I think Seb's talk illustrated this. If you have GPT-4 and you can prompt GPT-4, to create 20 billion training tokens because, you're OpenAI or Microsoft, that is an insanely powerful thing because now you can create new data sets using the foundation model, and now you can train better, incredibly good small models using this recipe. So there's a bootstrapping going on right now where you're building models, you're using the models to build data sets, you're training other models on those data sets, and you keep going up. And that I think is an exciting way of doing things.
Harry, see it?
I completely agree with that. I mean, I don't have anything to add, frankly.
Okay, I have a feeling that there are going to be a lot of questions. So what, who has a microphone? Jay, can you, yes, right here, go ahead.
Hello. First of all, I wanted to thank you all for your insights regarding like open data sets. I think it's actually really true. Like one major problem is that like these companies are privatizing these data sets, but they aren't like securing them. They're like licensing them and such, which means that there are other people, as long as they have enough money, are going to like buy them and use them for their own like purposes. And so like I think it should either be completely closed down and, no one should have like access to it, or it should like be completely open source. But one issue that I think might exist with open source like data sets, and you mentioned it like when you were like when you talked about crawling through like these social media websites for like, training data images, right? Is I feel like a lot of these images, and I don't have like a source for this, are like very would be very biased towards people who have access to social media platforms and post a whole lot of stuff, especially in like more developed countries, right? And if they do have images of like, lesser developed countries, it would probably be like just, tourist attractions and such, if that makes sense, right? So like,
is that your question or?
my question is like, do you think this bias exists? Like,
Yeah.
and like, how will this, do you think this will impact like, like security for like the way these models are used? Do you think this is something that, developed governments who, are like, where these social media platforms are prevalent, like, do you think this is something they should be worried about?
Yeah, I can take a first answer on some parts of what you said. There's definitely biases, of course, on the internet, reflecting the biases of as you say, where the data is coming from. There's a lot of effort on mitigating those biases with algorithms and also rebalancing methods and also prompting editing techniques and so on. So there's a big effort there. On the security side, I don't know if you want to add anything.
I mean, just think about it this way: the DoD, and I see the DoD in the room, are using AI systems that were trained on Instagram pictures. I mean, that's the world we live in, right? So to your point of bias is like, well, I think we need to pay attention to that, obviously. I mean, there's no security angle there. It's just, let's not do crazy things.
I thank you for this great discussion. I had a question about beyond sort of the technical aspects of model architectures and these recent deep learning based models. So with the example of self-driving cars, there are ethical norms and considerations. So there was a great article in Nature from several years ago that came out around if an accident is unavoidable, does the car protect the passengers? Does it protect the bystanders, the pedestrians? And it was a very interesting thing about just the ways in which cultural norms come into that, because there were different perceptions across the world. I was curious about the extent to which UT Austin is including these aspects of responsible AI as part of it, beyond the sort of the technical aspects, but sort of the decision making that goes along with these. So I'd be grateful for any comments around those lines.
And also, when will we have self-driving cars?
I'm not working on self-driving cars. Yeah, I'm not very much. I know there are a lot of efforts. I'm not very closely involved. There are other aspects of ethical issues that we are working on very much. So we do try to mitigate them. We try to measure biases. We try to measure ethical issues. But I don't have anything non-trivial to say about that because I don't have that much expertise. Yeah.
I mean, I've worked on responsible AI issues and I helped write the U.S. government write their responsible AI guidelines. Look, responsible AI is all down to these toolkits, these guides. You have to read them, right? And people don't like to read. So, we need to get to a point where responsible AI is baked in from a tooling perspective. And I think there's huge opportunity there from a venture capital perspective to back companies who are doing responsible AI from putting it in the workflow as opposed to just making developers read a document that we know they're not going to read.
And I was just going to add on and say that each time you're putting AI into the real world and a physical embodiment that's going to interact with humans, you're creating some level of risk that something will eventually happen. But we also have to consider whether those odds are improved upon a human making that decision versus a machine making that decision. I'm working with a friend who's a professor in Munich, and Gordon Cheng, he's working on humanoids, but again, his thought process is to get robots out in the real world. He's sensorizing them. He's giving them kind of a sensor-based skin. So interactions with living beings, be it the humans, animals, so on, can be, kind of gentle and kind of more subtle than we would expect from current machines. So we're going to see some of this evolution happen over time. But certainly we have to view it with the contrast needs to be between the effectiveness of human decision-making versus machine decision-making, and overall, how are we doing? Are we improving the odds? How are we improving chances for survival in an accident and so on?
We have Ben Fauber.
Hey, Adam. Thank you. I really appreciate this discussion. I think there's some great topics being brought up. You mentioned the breakthrough of AlphaFold and its contribution to the pharmaceutical industry. In thinking about the extension of that into relevant biomedical data sets, pharmaceutical data sets, things along those lines, PubMed and PubChem exist out there. They're both curated by the NIH. My understanding is if you receive an NIH grant and you participate in some sort of screening campaign, you have to upload your screening data to one of those repositories. The trouble is it's total garbage. And it's kind of one of those like box ticking exercises where they have some postdoc or grad student upload it to comply with the grant requirements, and that's it. And thinking about data comp and where data comp is headed, is there any consideration for starting to curate and clean up and think about biomedical and pharmaceutical data sets to really help humanity advance on therapeutics and diagnostics and bring some meaningful changes in addition to what we're doing with text and images and speech already with generative AI?
So I'll field that question. So I think people underestimate the difficulty of, as you said, a lot of these repositories are garbage. I wouldn't say garbage, but I think people drastically underestimate how difficult it is to get the data pipeline up and running to train models in, say, a bioscience space. We all sort of understand what language and text and images look like, but just the number of different things that you need to do to even understand, what, say, biomolecular data looks like and how it was formatted and how different experimentalists have uploaded it. It's really an order of magnitude more difficult, and I think it's a high barrier to entry for people who want to do AI in that space. And when we were talking to people at SynBioBeta, there's a company, Ginkgo, I mean, there is a database of hundreds of millions of protein sequences, and they went and shoveled some dirt in San Francisco and sequenced it and found that none of them were in the protein. I mean, the vast majority of them were not in the protein database. So there's all this data out there that you need the sophisticated sequencing machinery to really get your hands on. And I don't have a good answer for that, except that as we get better from an experimental point of view, there are companies now that you can sort of pay them to sequence this data for you, and that as more and more institutions can kind of get together and cobble together these data sets that they think are most valuable to build models. Hopefully we'll get there. But right now, yeah, it's a mess.
I
Oh,
was
go
just going to add real quick that I'm, looking at a few companies that are trying to revolutionize clinical trials, but it remains a very, very difficult problem because it's divided into two parts. Generative AI might suggest molecules that could help with a certain disease or treatment or so on. But then the next part is whittling them down into, because Gen AI will give you like 16 million, hey, go out and try all of these, but obviously it's not possible to try all 16 million, so you whittle them down. And then when you get to the physical molecules, that part of the process remains a very physical process. You have to try it out in the real world with, and it remains a multi-year, often decades-long process. So we'll have to work on both parts of that problem to get it solved.
Okay, well, I want to thank the panelists for very inspiring discussion. Thank you very much. There's two aspects of the AI and security. One is how AI technology can be used for increasing the security. The other is the security issue of the AI technology itself. So I'm going to ask a loaded question to cover both aspects. One is if a panelist can give some advice of, how can the AI technology, the machine learning thing to be used in the particular domain of the security testing. I'm working at ESSEC Information Security. We do the testing evaluation for security features of software, hardware. Speaking of the open source foundation, we work with all the Linux major distributors like Red Hat, SUSE, Canonical, Oracle, Amazon Linux. We do all the testing for the Linux kernel, API, the OpenSSL library, libscript, GNU-TLS, NSS, you name it. It's entire stack that people are using for the internet, secure the internet thing. The challenging here is when we talk about the larger language model and the data sets is so huge, we cannot throw our testing data to the public domain. It has to be some model is there, and we use the in-house data, and the security testing really has to respect, even for the open source foundation, each distributor has their own twist implemented there. When we work with proprietary technology.
I don't mean to rush you, but we're running out of
Right,
time.
right.
What's
Sorry.
your
Yes,
question?
yes. So basically, the question is if you have any advice of using the AI technology for the testing domain specific. The other side is, do you consider to introduce the cryptography to protect the AI model, the model, that the data, and so on and so forth? Yeah, thank you.
That was going to be my advice, to sign everything cryptographically. If you can get down to cell level signatures, and some companies have tried, that is really the best way to protect the supply chain of data, in my view, that's entering AI systems. And it's signed from author, obviously, so that you could verify it and then publish those signatures as well in a registry. So we do that for open source software as it is. There's no reason we can't do it for open source data sets.
I'm going to end the panel here. I know we have other questions, but they're going to be here all day. You can track them down. We're going to take a quick 5-minute coffee break. And then you're not going to want to miss Luke Zettelmoyer's talk, our keynote at 11. So we'll see you back for that. Thanks to the panel. Thank you.